Okay, so now we are going to get into the female reproductive system anatomy. And when I'm talking about this, I'm going to do a typical anatomic female, adult female. So we're finished with development and all of that, and we're going to assume just a typical anatomical adult female. So first off, I want to acknowledge something that you may or may not have thought about. Typically speaking, the students who do the absolute worst on the female anatomy are actually women. So it would be great if you guys showed that to be incorrect this semester. So the female reproductive system anatomy, it is a bit more obscure than the male reproductive system anatomy because, of course, a lot of the structures are internal. And so you haven't been seeing them externally. You don't see the ovaries, right? You do see the testes. You don't necessarily see the clitoris. Could if you looked for it, but you might not know where to look. You, of course, don't see as much of, you don't see the erectile tissue in the female externally necessarily. So it's a little more obscure. And then also, it's got some complexity to it, honestly, because it's got an extra functionality, at least one extra functionality compared to a male. Not only does it have to produce sex hormones and produce gametes, eggs, and a male does that too. It produces sex hormones and gametes. But in addition, the female has to prepare for and support a developing embryo and then fetus, and then, of course, go through the process of childbirth potentially. So there is a decent amount of complexity to female reproductive physiology. And, of course, the anatomy is more obscure. So you might have to study a little bit, is what I'm saying. Okay, so I want to take just a minute and talk about the menstrual cycle. I'm not going to do a complete job of it because you can spend weeks on this in human physiology, but I do want to talk just a little bit about what's going on with the menstrual cycle. So what you basically have, and let's go here for just a second. Okay, so we'll come back to this anatomy in just a second, but the thing I want to tell you is that the ovaries, which are the female gonads, are going to control what the uterus does, primarily by which hormones they are secreting at which time. And so what I want you to think of is the ovaries are, in a typical reproductive female, undergoing the process of meiosis and then development and then ovulation. And as they are doing this, what they are going to need to do is to tell the uterus where they are in the cycle. So, for instance, as you get close to ovulation, you're going to have to communicate with the uterus to tell it that it is time to thicken the endometrium in preparation for a possible fertilization and implantation. And then when that window is gone and there could not be a fertilization or implantation, the uterus is going to have to tell, the ovaries are going to have to tell the uterus to not this time, go ahead and slough off that endometrium and prepare for next time. So let's just look at that just for a second. I'm not going to hold you responsible for a ton of this complexity. So here's what's going on in the uterus, okay? We have this little cell called a follicle. Well, actually, the cell's not called the follicle. The thing that's supporting it is called the follicle. And this is going to undergo the process of meiosis, in which you take it from 46 chromosomes to 23 chromosomes. And then this is going to ovulate, okay? And when it ovulates, it's going to take a couple of days before it actually gets into the wall of the uterus. So notice that as you are getting close to ovulation, the uterine lining is building up in preparation for what could happen, which would be an implantation. And so what it's going to do is it's going to say, okay, ovulation is going to occur, and then this is ready in case fertilization and implantation occurs. If fertilization and implantation don't occur, what's going to happen is these hormone levels, specifically progesterone, will start to drop, and then it'll say, oh, it's not going to happen this cycle, maybe the next one. And then, of course, the menstruation is going to start, and then you start the whole thing over again. So what's really happening is the ovaries are releasing hormones that control the uterus. And primarily in the first portion of the cycle, it is estrogen primarily. And then in the second portion of the cycle, it is progesterone. Okay. And I won't hold you responsible for any of the levels of these because these are really hard to understand as far as levels. But what I want you to understand is the menstrual cycle is the ovaries telling the uterus what the uterus should do. Okay, so now let's get to the female external genitalia. The female external genitalia, guys, this whole thing is not a vagina. The whole external genitalia is called the vulva. It used to be called the pudendum, which was Latin for shameful. We have gladly gotten away from that terminology, although remember things like the pudendal nerve are still used. So not everything has changed terminology. So let's look at a little bit of the terminology. So the mons pubis is this rounded fatty pad that's overlying the pubic symphysis, which seems to have something to do with the fact that humans actually do end up having their pubic symphyses hit one another when engaged in intercourse, at least sometimes. So there's fat pad there. Males have a little bit of one too, but not much. And then the labia majora on the outside are homologous to what structure? Do you remember? Labia majora are homologous to the scrotum. So here's your labia majora and here's your scrotum. Okay, so the labia majora are homologous to the scrotum. And then we have the labia minora. The labia majora, by the way, after puberty generally will have pubic hair associated with them. And then the labia minora are the thinner inner folds that are hairless. And those are homologous to the skin that forms the shaft of the penis. Now, the labia majora is not homologous to the shaft of the penis. It's just the skin because it has all that erectile tissue in it in a male, and the erectile tissue ends up elsewhere in a female. So the labia majora are homologous to the skin surrounding the shaft of the penis. Okay, and then we have this region right here, the region inside the labia majora, which is collectively, it's in this line that you're seeing right there. It's collectively called the vestibule, and vestibule means waiting room. So, and it houses the opening to, here's the external urethral orifice right there. And then here's the vaginal orifice, the openings to the urethra and the vagina. And then some things that you may or may not realize are there. One of the things that I didn't realize were there for a long time is that right here, just kind of at the bottom portion, right toward the back of the vaginal orifice, there are openings for some glands, and the glands are actually behind the skin here, and you can see them in orange. They are called the greater vestibular glands, and those greater vestibular glands are responsible for lubricating the opening of the vagina, the vaginal orifice, during sexual arousal. And these are homologous to the male bulbourethral glands, which do really the same thing, right? The bulbourethral glands will secrete upon arousal in a male, and in a male they actually cleanse the urethra, but they also lubricate the tip of the penis upon arousal. Well, upon female arousal, the greater vestibular glands do something similar. Of course, they don't have anything to do with the urethra, but they lubricate the opening to the vagina upon arousal. And then there are the paraurethral glands or Skene's glands. And these are something that people still really argue about. So let me show you these. I'll talk to you about them a little bit again. So we're still not sure exactly what proportion of women have these. So people are still arguing about them a little bit. But when they exist in women, and they do exist at least in some women, where they exist is kind of right where the prostate would be in a male, which was, remember, kind of between the internal urethral sphincter and the external urethral sphincter. In a male, of course, that would be around the urethra. Here it seems as if the Skene's glands kind of exist right here between, here's the urethra and here's the vagina, right there. So when they exist, they seem to be homologous to the male prostate gland. And it's not like a whole gland, it's glandular tissue within that connective tissue. And when a woman has these, this glandular tissue, it tends to dump into the distal end of the urethra. And when it dumps into the distal end of the urethra, it can either be upon climax or upon arousal. We'll come back to that. And then the bulbs of the vestibule. Okay, so you're going to meet the first erectile structures in a female now. So the bulbs of the vestibule, again, this is when the skin is taken off, right? So what you're seeing here is the deep structures. They've got the superficial structures sort of imposed, but these are deeper structures. So the greater vestibular glands, we already talked about, that's those guys right there, right? And then these guys in the purple are called the bulbs of the vestibule. And the bulbs of the vestibule are the first erectile structures you'll learn about. What happens with the bulbs of the vestibule is when a woman becomes aroused, those engorge with blood, and they probably evolutionarily help to grip the penis when aroused during intercourse, which would make it more likely that ejaculation would occur. So here's your first erectile structures. And then this is these guys right here, the bulbs of the vestibule. This is a new type of imaging that, well, it hasn't been used much for the erectile structures, but you're seeing the bulbs of the vestibule right here. This is a pubic symphysis. Okay, we'll come back to the other ones. Okay, so that's all associated with the vestibule. But now I want to talk about the clitoris specifically. So the clitoris is much more complex than people usually think it is. First off, a lot of times when people are talking about the clitoris, it's too narrow, so they broaden it and say the female erectile complex, the female erectile complex. And what it includes is, if you look at this figure here, it includes the pink portion right here, which is the body and the glands of the clitoris. The blue portion right here, which is the crus, plural is crura, of the clitoris. And then usually people actually also include the bulbs of the vestibule. All of these structures are erectile structures. Of course, most of it is internal, so it can't be seen very much from the outside. Not all of it is internal, but most of it is. And interestingly, the female erectile complex doesn't have any reproductive function other than pleasure in the woman, and perhaps the bulbs of the vestibule may tighten the opening of the vagina and make ejaculation more likely in the male. And the clitoris is basically the erectile structures inside the clitoris. Most of them are homologous to the erectile structures that exist in the penis, and we'll talk about erections in penises a little bit later. But again, let's go back to this figure. So you've got the crus or crura of the clitoris. Oops, where did you go? Come back. You've got the crus in blue. You've got the body and then the glands of the clitoris and the bulb of the vestibule. And if we look at it again here, so the body and the glands of the clitoris, the crus or crura of the clitoris, and then the bulbs. Okay, so the way that this works is the same way an erection works in males. The crus or crura of the clitoris are smashed back up against the bone, the body wall, and they are continuous with the erectile structures in the body of the clitoris. And so when a woman becomes aroused, all of it engorges with blood. And since the crus or crura are smashed up against the bone, think of it like a pool float. If you start blowing up a pool float and it's smashed against the fence, what it actually does is stand up. So the body of the clitoris will actually stand up and become erect upon arousal. Interestingly, since the clitoral complex doesn't have a reproductive functionality other than pleasure in a woman, and there's been a lot of really puritanical times in our history, the structures of the clitoris have only really been consistently published and consistently communicated since 2009. I'm not saying people didn't know about them, but even in, for instance, Gray's Anatomy, which used to be sort of the Bible of anatomy, when we went through very conservative times, the structures of the clitoris were just removed from the textbook. So in like the 1950s, it was removed, and then it went back into the textbook, and then in the 1980s, it was removed again. Don't think that's ever going to happen again, because now we have the internet and you can figure out what the anatomy actually looks like. And I'm not talking about that kind of internet. I'm talking about actually anatomy. Internet. So let's think just a tiny bit more about this. The erectile structures within the clitoris are homologous to the erectile structures within the penis. The glands of the clitoris has 8,000 sensory nerve endings. And it is generally covered when a woman is not aroused, partially or completely by the prepuce, which is a covering of tissue. By the prepuce, there's also a prepuce of the glands of the penis as well. So the prepuce here you can see is covering partially. And the body of the clitoris has erectile tissue. The body of the clitoris has erectile tissue that is homologous with the paired corpora cavernosa, and they extend backwards, like I said, as crus or crura. So that is the female erectile structures. Okay, so now